Hi, my name is John Cox. I'm a retired firefighter with the City of Columbus in Ohio. And this is Jerry Knapp. Jerry, you want to introduce yourself?
My name is Jerry Knapp. I'm from Suburban Tactical Fire Training Incorporated.
We're out here today at Valparaiso MAC training facility in Indiana. And while we were out here, we came across this training aid that we thought would give us an opportunity to describe how natural gas is delivered to a residence or a commercial structure. First, I'd like to start out with the meter setting that most of us are familiar with. We have the riser, the shut-off valve, and a regulator. As a firefighter, as I approach this scene, whether it be on a working fire, I want to take a look at this valve and see if the gas is even onto this structure. In this configuration, it is in the off position. If we turn that valve a quarter turn, it allows the gas to pass through, entering into the regulator. The regulator regulates this elevated pressure coming from the main, regulates it down to a operating pressure in the house, which is typically less than a pound of pressure. And from here it goes into your gas appliances. These configurations you see here are a newer system. I don't want to call them newer systems, but they're compared to the old systems that were black iron steel risers. Now we have flexible risers, and a lot of times you can tell by the type of pressure you might have coming in according to the size of pipe. Here they've got a half-inch piece of pipe taped to this that would indicate that if they were using this size of pipe, maybe it was a higher pressure. With a lower pressure, you need a bigger diameter pipe, such as this 1-inch CSST. It's very important for you to maintain a relationship with your utility companies and understand this. If you don't understand this equipment and how this is distributed, and you arrive on the scene of an accident, a leak, typically in the fire service, we'll say send us the gas company. The gas company will send a service rep out, and if this happens to be a main line leak, that service member can't do anything about that. And they'll have to request a plant crew, which is going to delay their response. That crew could be digging somewhere and have to load their backhoe up. So if you've got a good understanding of the distribution system and what you're looking at, when you notify the gas company that you have a leak, you may be able to indicate to them, hey, we got a main line leak here where the backhoe pulled the T off. They're not going to send a serviceman. They're going to get that crew started a little bit sooner that can actually fix that leak. To give you an example, here in Ohio, this shut-off valve, typically this riser will go down, this pipe here will go out to the main, and there'll be a large shut-off valve similar to this underground. But in Ohio, they're starting to use what we call an excess flow valve. And what this does is this senses pressure loss from the main to this regulator. So if this outside line is broke anywhere, it automatically senses that excess flow and it shuts it off. I once had a run that, and I didn't know about these, and I was out at the street looking for the shut-off valve because I didn't know they had these in there. The gas company showed up and said, what are you looking for? I said, shut-off valve. They said, don't have one. So that's a good example of why you have to maintain a relationship with your utility companies and keep up with their modern technologies. Now, this is all outside stuff. I'm going to let Jerry explain a serious hazard that, in the fire service, most people don't know about as far as it relates to this.
As firefighters, our job, especially at gas leaks, is life safety. We're not the find and fix guy, we're not the plumber, we're the life safety guys. So I want to introduce you to a new life safety hazard, especially related to gas, called CSST, corrugated stainless steel tubing. This flexible tubing is very similar to what you have behind your stove or your dryer. This is replacing the black pipe that John just described, a very rigid and strong black pipe. This is very flexible. The reason we use this, or the reason it's used in new construction and renovations, is it's faster, cheaper, easier to put in. It also introduces a life safety hazard for us. In a building that has a CSST, if there's a lightning strike in the area, the ground gets energized by electricity. If the CSST is close to something else metal, a pipe, a truss, a nail, whatever it might be, if the ground is energized, if the CSST is energized, it can arc and poke a hole in the CSST. What happens then is you get a fire, and typically a lot of this piping is in the basement. You'll get multiple ignition sources in the basement. By the time we get there, it shows as a first floor fire. And what ends up happening is, and there's been a couple of line of duty deaths just happened this way, is through the door, through the floor. Guys fall through the floor and end up dying in the basement. It's being used all over. It's kind of like trusses. It's faster, easier, cheaper to put in. You can go to your big box store and in 10 minutes you can get certified to put it in. I'm not sure that's all the training that's required. Again, the purpose of this is just to give you an introduction, to introduce the CSST hazard to you. You need to do a lot more research in this short video, but just be aware it's a hazard now that we face for our life safety mission.
Jerry, could I add one more thing to that?
Sure.
So where I talked about this regulator reducing the pressure down to less than a pound, typically what they'll do when they run this is they'll have a regulator out here that reduces the pressure, but not down to a pound, but down to a couple pounds. So you got maybe 60 pounds coming in, you got 2 or 3 pounds coming out. I don't know what the regulation or code is for it, but you still have a little bit of elevated pressure going into the home to another manifold setting with a regulator that regulates it down to the operating pressure. And where that creates a little bit of a problem is if this line gets broke somewhere between here and that regulator on the manifold, now you have elevated pressure blowing into a house that'll fill that house a lot faster than if it had just low pressure, less than a pound going in there. So there's multiple hazards to this. When I worked at the gas company almost 30 years ago, they were just starting to put this in. So it is, we like to say it's new, but it's kind of not new.
Yeah, there's millions of feet of it
And
out
I
there.
do believe they've come out with a different style that's grounded a little bit different, but I have been on a lightning strike fire where the engine officer called me the following day and said when the gas company arrived, it had blown a hole in the pipe. So not only are we in there fighting this fire with an SCBA on, we typically don't take our monitors in on the initial approach into the home. So we're walking around, we can't smell because we got our mask on, we don't even know we're operating in an environment where there's gas blowing. So if you get sent on a lightning strike fire, it's very important that you get to the meters and get that meter shut off, because if you find out 10 minutes into it that it has this stuff, there could be the possibility of blowing gas in that residence while you're fighting that fire.
And I think it's really important. We wouldn't think of a gas leak at a lightning strike, but with the new products like CSST, there's a good possibility. Like John said, there's gas flowing. There's maybe multiple ignition sources in the basement. I'd recommend you look at 2 line of duty death reports, Josh Laird and Nate Flynn. They were both killed in exactly the same scenarios like this. Again, this short video, we can't make an expert CSST, but look at those line of duty death reports. It'll give you a good background and possibly help you at your next call.